This is the activity on finding the curved surface area of a cylinder. The objective of this activity is to find the curved surface area with the help of an activity with the help of some paper strips. Let's see the concept in hand first. What do you mean by curved surface area? So whenever you have anything which is circular, like a cylinder shape, this is circular all around and flat on the top and at the base. So the curved surface area is the area all around. That means the area excluding the flat surfaces. So this area is called the curved surface area. How do you make a cylinder? We first take a rectangular paper strip and then fold this along the length. So what will happen to the length? Length will become the circumference of the circular part, that is 2 pi r. This length will become the circumference of the lower base. And what will happen to this area? This area will actually become the curved surface area of the cylinder. So if you assume that the length is L and breadth is B, length L converts to the circumference of the top or the base, and the base gets converted to the height of the cylinder when you fold it into a cylinder. And obviously the area of the strip, that is the rectangular strip, gets converted to the curved surface area of the cylinder. So the area of the strip was length into breadth. Length has been converted to 2 pi r and breadth to height, and therefore the curved surface area of the cylinder will be equal to the area of the paper strip, which is 2 pi r h, and that is the formula for finding the CSA of a cylinder. The material required to conduct this activity are a colored graph paper, pencil, then geometry box, scissors, glue. These are all general material which we require. We require the drawing sheets also, and one cylindrical can, so that we can practically see how the rectangular sheet gets converted to the curved surface area of a cylinder. Let's perform this activity now.
So in this activity, we are attempting to find the total surface area of a cylinder by using a rectangular sheet of paper. This rectangle, suppose this is the length of the rectangle and this is the width of the rectangle. Now what happens when you fold this rectangular sheet of paper to convert that into a cylinder? You have to fold it along the length. So the length will get curved. So this will be like this, and when you hold the two free ends, it will look like a cylinder. So here I have made a cylinder already using that rectangular sheet of paper. So what happens to the length when it becomes a shape like this? Here is the length. It becomes the circumference of the top face or the bottom face, and therefore this L in the rectangular sheet of paper is actually 2 pi r. That is the circumference of the base. And what happens to the breadth? Here is the breadth of the paper. Breadth becomes the height of the cylinder. This is the height of the cylinder now. So the area of this sheet is actually equal to the curved surface area of this cylinder, because the entire area gets converted into the curved surface area. So the curved surface area is length into breadth, that is equal to the area of this sheet. And length into breadth means length is 2 pi r and breadth is height, so 2 pi r h. Now this becomes the CSA, or the curved surface area of the cylinder. Now if we have to calculate the total surface area, we need to add the area of the base and the area of the top face. What is the shape of the top? It is a circle. And what is the shape of the base? It is the same circle. So if you add 2 pi r square, that means area of two circles, one on the top and one at the base, then it becomes the total surface area of a cylinder. So curved surface area was 2 pi RH, and we added two circles, that means 2 pi r square to that. If you take 2 pi r as the common factor, you will have h plus r in the bracket, and that gives us the formula for total surface area of this cylinder, which was formed from a rectangular sheet of paper. And that completes our activity on finding the total surface area of a cylinder.